Okay, this is Unit 6, Lesson 9, dealing with negative numbers. And our focus question, what strategies can you use to solve equations that involve negative numbers? So far we've worked with a lot of equations with positive numbers using the hanger diagrams and the tape diagrams. But now we have negative numbers in our equations. So let's look at our warm-up question. Which equation doesn't belong? So some of you might have said that this one here doesn't belong because it's the only equation that has a number on the left side and an operation on the right. See, all these have operations on the left. Something else you might have said was this was the only one with addition. Or maybe you said this one, it's the only one with subtraction. Let's solve these and see if they have the same answer. Negative 5 times negative 3 is positive 15. 2 plus negative 5 is negative 3. 4 minus negative 2 is 6. And negative 3 times negative 4 is not negative 12, right? A negative times a negative is a positive, so this one's false. So you may have said this is the only one that's false. So there's different ways of looking at those problems. Okay, 9.2 says solve each equation, be prepared to explain your reasoning. So this first one's pretty straightforward. We have an x plus 6 is equal to 4. And this is, we know that we have to add a negative number to 6 to equal 4, right? So what number could we put in here for x? We could say it's negative 2. Or if we were thinking about it as a hanger diagram, we have an x and then 6 ones on this side. So if we want to get the x by itself, we would subtract 6 from both sides because we want to keep that hanger balanced. And in this case, we want to keep the equation balanced. So it would be x is equal to negative 2. Let's look at number 2, because number 2 has some negative numbers in here and subtraction. And when you think about a hanger diagram or a tape diagram, it doesn't make sense to have a negative weight, right? This doesn't make sense to have a negative weight. But we could still use the same idea of doing one operation to each side of the hanger, or in this case, each side of the equation. So if we have x minus negative 4 is equal to negative 6. We want to take away this negative 4, right? So we would subtract negative 4 is equal to negative 6 minus negative 4. We do the same thing to both sides. When you subtract a negative number, you're adding, right? So if we would change this, if we change this around, we want to make this into keep, flip, change, right? We change it into an addition problem. X plus 4 is equal to negative 6. Then we would subtract 4 and subtract 4. And it would be x is equal to negative 10.
Positive there. If I don't want to, I'm still going to.
So for number 2, we have x minus negative 4 is equal to negative 6. So if I want to get this x by itself, like if we were thinking of a hanger diagram, we're getting rid of those squares we're adding, right? To get the x's by itself, to get the variable by itself. I'm going to do that without the hanger diagram. If I have x minus negative 4 and I want to get this by itself, I would need to add negative 4. And I need to do that to both sides. So subtracting a negative 4 and adding a negative 4 would be 0. So now I have x is equal to negative 6 plus negative 4 is negative 10. Or an easier way to think about this may be to change this to addition, right? If we have x minus negative 4 is equal to negative 6, remember any subtraction problem we could change to addition. We just do keep, flip, change. And now we have x plus a positive 4. So if we have x plus a positive 4, then we would just subtract 4 from both sides. And we would come to the same answer as over here. Negative 6 minus 4 is negative 10. Okay, let's look at number 3. Number 3 says 2 times the quantity of x minus 1 is equal to negative 200. So we have two groups of x minus 1. If we just want to know what the x minus 1 is, we would divide by 2 and divide by 2, and that would leave us with just the x minus 1 is equal to negative 2 divided, or negative 200 divided by 2 would be negative 100. And now, if we want to get the x by itself, we're subtracting 1, we would need to add 1 to both sides, and we would end up with x is equal to negative 99. And if you prefer, you could use the distributive property to solve this. Oops. If we have 2 times the quantity x minus 1 is equal to negative 200, we could use the distributive property to remove the parentheses. So 2x minus 2 times 1 is 2 is equal to negative 200. So we would add 2, and we would get negative 198 is equal to 2x. We divide by 2, divide by 2. X is equal to negative 99. We come up with the same answer. Okay, let's look at number 4. Two x plus negative 3 is equal to 23. So you might start noticing now, as with the hanger diagrams, keeping the hanger balanced. What we did to one side, we did to the other side. We're doing the same thing with these equations. What we do to one side, we do to the other side. And our first goal is to get the x's, the variables, by itself, right? Here we have 2 x's, and we want to get that 2 x's by itself. So if we're adding a negative 3, we need to subtract a negative 3. Or we could change this. If we add a negative, it's the same thing as subtracting a positive, right? So this equation could look like 2x minus 3 is equal to negative 23. So going back to this one, if we subtract a negative 3 and we subtract a negative 3, here we would add 3 and add 3. So we'd end up with 2x is equal to negative 20, or subtracting a negative, keep, flip, change, right? We're adding negative 3 plus positive 3 is 0, so we end up with 2x is equal to, keep, flip, change, negative 23 plus 3, negative 20. We end up in the same spot. So from this point, we have 2 x's, so we would divide those 2 x's by 2 to get 1x, and that would divide this side by 2, and x would be equal to negative 10. Okay, let's look at 9.3. Here are some equations that all have the same solution. So x is equal to negative 6, and that's true in all of these. And number 1 says, explain how you know that each equation has the same solution as the previous equation. Okay, so let's take a look. What is happening from here to here? Well, I can see that this is x, and this is x minus 3. So what they could be doing is subtracting 3 from both sides, right? So x minus 3 and negative 6 minus 3. X minus 3 is, I don't know what x is, so we can just put x minus 3 is equal to negative 6 minus 3 is negative 9. And that's what we have here. So how did they get from here down to here? So it looks like they just switched these around, right? The x minus 3 is now over on this side, and the negative 9 is over on this side. So they're still equal to each other. They just switched them around. So now, how did they get from here to here? And from here to here? Well, we could see, let's see, negative 9, well, they didn't add, because there's not addition over here. It looks like they multiply. They have x minus 3. They have x minus 3, and now it's multiplied by negative 100. If we take negative 9 and multiply it by negative 100, a negative times a negative is a positive, so this would be positive 900. So they multiplied negative 100 to this side and negative 100 to this side. And now what did they do? Nothing changed over here, but over here, it looks like they just switched around the 100 times the quantity x minus 3. So they just switched these around. And the commutative property of multiplication says that's okay. It doesn't matter what order you multiply in. So now, how did they get 100x plus 300, and this 900 stayed the same? They didn't do anything over here. They just changed the way this looks using the distributive property. They took negative 100 and they distributed it. Negative 100 times x is negative 100x. Negative 100 times negative 3, or minus negative 100 times 3 is negative 300, and keep, flip, change makes it negative 100x plus 300. Okay, let's look at number 2. It says keep your work secret from your partner. So normally you'd be doing this with a partner. Start with the equation -5 equals x. Do the same thing to each side at least 3 times to create an equation that has the same solution as the starting equation. Write the equation you ended up with on a slip of paper and trade equations with your partner. So to do this, we would start with -5 is equal to x. And we want to do the same thing to each side. So maybe I add 5 to each side. That's not a good one. So we're going to start with -5 is equal to x. So maybe I add 2 to each side of this. So if I add 2 here and I add 2 here, I end up with -3 is equal to x plus 2. So that's one thing I did. I added 2. That was step 1. Step 2, let's see, I can let's use the let's multiply. So I'm going to take this whole side and I'm going to multiply it by -2. I'm going to take this side, I'm going to multiply by -2. So -3 times -2 is +6. So I end up with 6 is equal to -2 times x plus 2. And for the third step, so just to review, well, I'll go do that last. So now here I'm going to use the distributive property and distribute this out. So I'm going to end up with 6 is equal to -2 times x, which is -2x. And then a -2 times a +2 is a -4. So my first step, I added 2. Second step, I multiplied -2. And the third step, I used the distributive property. Okay, let's go to our summary. So how do we solve equations that involve negative numbers? So solving equations with negative numbers is the same as positive numbers. Doing the same thing to each side of the equation still keeps the equation balanced. So here's an example from our lesson today. Here we have a -3 or subtracting 3. And we have a -23 over here. So if we look at this side, 2x minus 3, we add 3 to both sides. And we divide both sides by the same number to find our solution. Now, one thing you want to remember when you're dealing with negative numbers, you have to remember your rules of multiplication or addition and subtraction or division. When you deal with negative numbers, you have to remember a negative times a negative is a positive. If the signs are different, they're negative with multiplication and division. Or if you're adding, big number minus little number gives you your answer, and then you use the sign of the big number. Or if both signs are the same, You add the numbers together and use whatever sign they have in common. So you need to remember those rules. Those aren't going to change.